Alright, so this is Sprint 5. This week we had to do the terrain. So this is what we have so far. It's completely done. We have a lot. We have the model, we have a flat and a wireframe, so that we can display both textured version and the wireframe, mostly for debugging purposes. We have the pverts and tlists, which we don't keep for long. We get rid of them fairly quick. And then we have a list of all of our cells, a list of all of our normals, and then these are all just stuff, information to help us set up and do operations throughout the rest of the functions that we have. We have different ways of accessing indexes. Cell, for example, will give us the, given a I and j, what's the cell index we need to access the correct cell within cell list. Things like that. And then we have these position to cell index. We had to do sealing for collision, which I'll get into later. Draw, this is just so that, when the player, because currently the player owns the terrain, it's not hooked up to the engine. So player passes in the camera so that the terrain can draw itself. Highlight, highlight all, and intersect were the three tasks that were given to us. Currently only intersect is being shown because, well, intersect basically builds up off of the previous two, but highlight all and highlight still work. Get height, which is for getting the height according to barycentric coordinates. Get normal is the same, but with normals. And then this is just for in the future, because I know I'm going to need this, especially for when I want something to when it passes through the ground level or something. So that's the header file. I'm not going to go too much into the CPP file because there's a lot and it would take me way too long to get into it, but I'm doing a quick scroll by. And this is all currently, we're still in the constructor. Right here is where the constructor ends. 200 lines of code just for that. But once it's all done, once it's all made, we have a pretty easy time. Tons of math for position to ceiling, because we use floor here and ceiling here. This is because the reason we need this is because the floor would sometimes cut off squares that we needed for collision testing. So with like the very edge of the tank would be on a square of the terrain, but it wouldn't be recognizing it because of the floor function. So we added in a ceiling function. And I tried the round function and it was better, but it wasn't perfect. This, on the other hand, is perfect. It's just a little bit more code that clogs it up. Highlight highlights the one square underneath the x and y chords. Highlight all highlights them all according to the default sphere. Intersect also does the same given a game object. Tests against the default sphere first, right here. Intersect against the default sphere and the given cell that we have. If that goes through, then we test for the actual collision volume. And we have a tiered color system so that we can easily tell which squares are where. Get height, and then this is all the barycentric coordinates. We calculate the beta, and I don't know what the other one was called, so I just named it x beta, z beta. We calculate those according to the simplified math that was given to us, and then we get p height and return that plus the y offset of the terrain. Get normal is the same, except this time we're doing it for the normals, so we're returning that instead. And then at the end, we delete everything that we have. So that's the terrain. And I guess I'll just show you right now, and I'll keep talking about it. So as you can see, we have this is a custom terrain that I made, went ahead and just created. As you can see, all of those squares below us are green. That means that they're not even intersecting with our default B-sphere. If I die, I'll just restart. So if I move up this hill, the very top of the hill is at y equals 0. So as you can see, they're yellow. That means that they're in the B-sphere, but they're not actually colliding with the tank. and then the ones at the very top are red, so those are actual collisions that we're having. If I move back, you'll also see there's this right here. This is the position and the normal, the height and normal of what's directly below the tank. And it's computed using barycentric coordinates, because you can see it's very, very smooth. Very nice. And if we go up the other hill, it'll be more of the same. So that is all of our terrain done for this week. Moving on to the personal project, I found a building to use. The code for it all works, so if I were to shoot it, it will disappear. The texture, however, that was given, this was a model from the internet, the texture with it almost works. It's just close enough. But it's just off enough that you know it's wrong. So either I keep it and it's slightly wrong, or I go for a plain color. I am leaning more towards the just keep it, so that we have at least something. Also, real quick, I want to show that going off the terrain doesn't crash the game, but it does cause very weird things to happen, as you can see, especially with the normal. But hey, at least the game is still running, and the player shouldn't be going off of the edge of the terrain. So, you know, I'll take that. Moving on to just real. I also did not show the bomb, which we have now. The plane is also not doing its jittery effects anymore. So that is the bomb right there. It drops it every 3 seconds. It goes down when it hits something, or if it reaches y equals 0, it will explode, which will cause a big sphere. It does a ton of damage. As you can see, I'm at 1 HP. That was all from the bomb. So they're very deadly, and I can easily change the scale of it if I want to, make the explosion bigger. And later on, when my particle effect system is done, it's also going to be spewing out like smoke and fire. It's going to be very neat. But yeah, the plane is moving very smoothly now. I'm very happy about that. So that was the work for the game. We have the bomb, the plane, the building is done. Now all we have to do is make the levels and do some very specific things with the UI. And from here, it's basically just level design. So the game is coming along very nicely. The particle system, as per our discussion before, I've started an animated sprite class. It's in the very early stages because I've only had a couple days to work on it, but I do have a few ideas about it that I'm going to talk about. As you can see, I have a texture pointer for the sprite sheet. This is going to be like the full sprite sheet that we're given. It's not going to be chopped up or anything. Those are going to be stored within sprites. We're calling them frames. I'm going to be storing them as sprites. We're going to be using a similar thing to the sprite font. So if we go in here, we can see that we're loading in using rectangles, and then we're storing it within a map. And then when the user wants a specific one, they're given a pointer to the image. They're not given the actual image. All that is kept with the sprite font. And I'm thinking of doing something similar with the animated sprite. It's going to be the owner. We can lend out the frames, as we can see, and people can use them, but we are the original owner of that, of each of those frames. So from here, I have two options, really. I can have, because the particle effect is going to have the parent sprite, I guess. Okay, so option 1 is that the animated sprite is, we use just get frame. The animated sprite doesn't animate itself at all. The burst is completely in control of that. So basically, this would be done for the animated sprite. It would, if I just made a class and gave it an animated sprite, it wouldn't move on its own. That would be controlled by saying get frame of this index. Okay, keep displaying that, and then change the index, keep displaying that, keep displaying that. The other option is to have one parent animated sprite, so that would be within the particle effect. This parent animated sprite would control the sprite sheet and the frames, so we don't have to duplicate all of that all the time. But we also give it the power to animate it by itself, meaning each burst, since bursts are created at the same time, they would have the same frames of animation. Each burst would have a copy of the animated sprite. It would have the same pointers. It would point back to the sprite sheet in Real, but it would be able to animate on its own, and that's where current frame would come in. So you could set the playback speed, you could set whether it loops or not. Currently, I'm leaning towards the second option since it offers the user more flexibility, especially if they want to take this outside of the particle system, so that they can actually use it. But worst case scenario, if this doesn't pan out for some reason, I can go back to the first option. It limits the usability of this quite a bit, but it's a lot simpler to implement. So that's what I wanted to talk about with the animated sprite. Also, for the when the sprite gets chopped up, it's going to be stored in an array, a plain array. The reason for this is that I don't need the added usefulness of inserting and deleting, since once a sprite sheet is given, I'm going to assume that there's going to be no changes to it in the middle of the game, and I don't need any added iterators really. Since I have indexes, I can just say real at position 4, and I'll know that's good. And there's nothing that I really need that vectors or lists offer me that I think I need at this moment. So currently I'm going with just a plain array, and that might change down the road, but I doubt it. The burst is also coming along. We have the factory and pool set up for it. The emitter is in the very early stages, and the particle is completely done. We also have billboarding done as shown last week. This is the particle class, very simple. I tried to make it as small as possible. We have position, velocity, gravity, and then angle and angle change, and then just very simple functions, making it as lightweight as possible. And then the factory and pool are also set up. So that's the progress I have on my personal project as well, and I believe that is everything. No, right. One more thing. For the animated sprite, if I do end up going down the road of letting the animated sprite animate on its own, I also have the additional problem of deciding how I'm going to time it out. So if the user wants the image to change every second, do I use the alarmable manager, which seems like a very bad idea, considering it'll clog it up a lot, and I don't want to trust it that much. Or what I'm leaning more towards is using the time manager and accessing the time, subtracting that. So yeah, those are all the thoughts I've had so far, and that is everything.